Our next speaker is Martin Crawford. In 1992, Martin founded the Agroforestry Research Trust and has since written books on forest gardening. To give you a sense for his methods, here is a brief visual for you.
If you do nothing to a piece of land in temperate climates, it will become a forest. The forces of nature are actively moving the land towards a balanced, sustainable, and resilient ecosystem. This is called succession. In southwest England, an unusual forest is growing. Nut trees, fruit trees, shrubs, and perennial vegetables are planted in a way that mimics a natural woodland. This forest garden is the life's work of Martin Crawford, an unconventional gardener who grows 500 edible plants with just a few hours of maintenance per month.
What we think of as normal in terms of food production is actually not normal at all. Annual plants are very rare in nature, and yet most of our agricultural fields are full of annual plants. It's not normal. What's normal is a more forested or semi-forested system. Forest gardens in a temperate climate tend to have 7 layers or so: high trees, smaller trees, shrubs, perennials, ground cover layers, root crops, and climbers. So it includes directly useful plants, many types of fruit trees, both the common ones and much less common fruit trees, all the types of nuts, tuber crops, vegetables, medicinal plants, timber, but also logs that you might grow other things on, like mushrooms. There are also plants of indirect use, system plants, to help the system function better, and that includes nitrogen-fixing plants, mineral accumulators, plants to attract beneficial insects to eat all your pests. Forest gardens are very beautiful places to be in, because although they're managed, the management is light, so they have this very naturalistic feel to them, and it is more like being out in nature than being in a cultivated garden. It can seem a bit overwhelming. There's so many different species. You shouldn't let that stop you from beginning a project, because you don't have to know everything to begin with. Just start, plant some trees and go from there. It's not the gradually increasing temperatures that damage plants. It's the increase in extreme events, big storms, big winds, very heavy rain, hail, droughts. By having a very diverse system, whatever happens to the weather, most of your crops will probably do fine. Some may fail, some may do better. That's very important going into the future, because we don't know exactly what's going to happen to our weather. So by having a diverse system, it gives you maximum resilience.
And with that, I welcome Martin Crawford.
Hello, I'm Martin Crawford from the Agroforestry Research Trust, and I'm going to talk about maximising soil carbon storage in food forests. So I've been growing and researching food forests and forest gardens for the last 30 years. And this subject, of course, is of critical importance. We've got to start storing more carbon in our growing systems. And doing it in food forests is one of the best ways we can do that. So I'll start off just by a little bit of framing, and probably a lot of you watching this will know this stuff, but bear with me. This and the next slide are a fantastic paper by scientists in 2018 showing what's going to happen to the Earth's climate, basically, depending on what we do. And the Earth is a little ball there, marked at point B. In fact, it's a little bit further along the way to point C by now, 3 years later, than it is there. And we have a very short window of opportunity to stabilise the Earth's climate. If we don't do that, there's going to be runaway climate change. And it runs away because of the tipping points in the Earth's climate regulation system, which are shown on this slide here. And some of these tipping points are very close. In fact, some of them may have passed already. We won't really know until we can look back far enough. But things like the Arctic summer sea ice and Greenland ice sheet tipping points, they may have gone past already. That might be irreversible already. And the risk is that if one or two more of these tipping points flip, then it'll cause a cascade flipping other tipping points, and the Earth's climate will go into extreme change. And the only way, of course, we can avoid that at the moment is taking carbon out of the atmosphere. And the only way we have doing that at the moment is storing it in our growing systems. So that's the foundation behind my reasoning for this. So what should our goal be for all growing systems? Well, to sequester and store as much carbon from the atmosphere as we can over the next few decades. I think this is more important even than looking at things like yield and productivity of growing systems. First and foremost, they should be storing carbon. And then most food forests will sequester carbon anyway, just by the fact that they are growing with the woody species and so on. But with certain techniques and certain options, we can maximize this. And they're what I'm going to talk about during this rest of this presentation. What can we do to really maximize the amount of carbon we draw down? So, how to maximize carbon into the soil? Well, first of all, maximize the rate and amount of carbon sequestration in the biomass of the growing system. Secondly, to maximize the rate of transfer from the carbon in that biomass into the soil, where it is more stable. And lastly, minimize carbon losses from the soil. So by a combination of those three things, we can actually store a lot of carbon very fast into the soil. So, looking first at maximizing the rate and the amounts of carbon sequestration into biomass. This is in food forests and forest gardens now. Firstly, try using high density planting systems, using nurse trees and nurse shrubs. By high density, what do I mean? Well, probably a tree or a shrub maybe every 1 to 2 meters apart when you plant. That's very high density, higher even than for forestry density planting, which is normally 2 to 3 meters apart. And this has some interesting crossovers with the ideas of syntropic agriculture, which also uses a high density planting system. The idea is by high density planting, you get a lot of woody growth very fast. And of course, that has to be thinned out within a shortish period of time. You're talking usually 5 to 10 years before those nurse trees or shrubs, which are interplanted in between all your crop trees, start competing too much, particularly for light, with your crop trees. So using a high density planting system does require more input and more maintenance in those first 10 years in terms of careful observation of how the system is progressing and pruning out or cutting out completely those nurse woody shrubs or trees before they compete too much. Use of nitrogen fixers is very important. The use of nitrogen fixers increases the rate of carbon sequestration. So because it makes your plants grow faster, it makes your woody plants grow faster, and so they store more carbon. So it makes absolute sense. Of course, in food forests, a lot of people are going to be using nitrogen fixers in any case. For nitrogen feeding, for their crops, a lot of them are fantastic pollinator plants as well. So you can see some of them in the photos here. Some are quite well known, some less well known, but they should definitely be incorporated into your system. Maximize resilience to climate change. Well, this is easier perhaps said than done, but maximizing resilience to climate change means, in effect, maximizing the diversity of plants in your growing system. And not only plants, maybe other organisms too. And that's because the threat to growing systems from climate change is not so much from gradually increasing temperatures, although that will be happening in most places, of course. It is from the increase in climate extremes. So it's the increase in floods, in droughts, in strength of storm winds, etc., etc. And all those things affect different plants differently. So if you can maximize resilience by maximizing diversity, then even if one or two of your crop plants get hit badly by something that climate change brings along, the rest will be fine. Maximize the use of large, fast-growing trees. They're the ones that store most carbon in their biomass. And of course that's why forests tend to store more carbon than anything. But the thing is, in a food forest, we're not growing a forest, we're growing a food forest. And that is very different in that it's much more open. You've got to allow enough light in for your lower crops to be productive. That means limiting the number of large fast-growing trees. So you've got this interesting contradiction, really. You want maximum use of large fast-growing trees, but you don't want too many. So you've got to obviously come to a balance there and compromise somewhere in the middle. But you should definitely include large fast-growing trees. I mean trees that might grow 15 meters or 20 meters high relatively quickly. I often use alders, for example, for doing that, particularly Italian alder, which does very well in our climate and stays narrow and conical, so it doesn't shade too much other stuff below it. Try and include those in your growing systems. Obviously, very small forest gardens, you just won't have room for large, fast-growing trees, so you have to compromise there. But larger ones, yeah, definitely include those. Include especially deep-rooted trees and plants deliberately. Some of the plants you might choose in a food forest will be deep-rooted in any case. Shown here are comfrey on the left, symphytum, and black walnut juglans nigra on the right, both of which very well-known deep-rooted plants. There's good evidence, solid evidence, that deep-rooted plants help deep-rooted carbon storage. Now, when you read figures about carbon storage, most people have only ever looked in the top 30 centimetres, the top 1 foot of soil. And of course, for things like annual crops, that might be relevant. But when you're talking about perennial crops and tree crops, that misses a load of the carbon. Carbon storage can go 3 or 4 meters deep, but it won't do that unless the roots also go 3 or 4 meters deep, because it needs the roots down there, in combination, of course, with mycorrhizal fungi, to be able to sequester the carbon into the soil deep down. And so you've got this potential really deep carbon store beneath you in the soil. And by including really deep-rooted plants, you increase the potential of that store tremendously. It can be total carbon storage can be 2 or 3 times the amount in the top 30 centimeters overall. That's an incredible increase, over the bit in the topsoil there that is often measured. Maximize the use of perennial crops and perennial diversity. So again, there's very good evidence that maximizing perennials maximizes carbon storage or carbon sequestration in soil. There's been good evidence, comparing perennials to annuals, that perennials store more carbon, and there's also good evidence that increasing diversity increases carbon storage. So both those things make a lot of sense, and of course most people in their food forests are going to be doing that. But I'm often asked, well, how diverse is a lot of diversity? What is high diversity? And it's not that easy to put a figure on, because there isn't a fixed figure that I could say this is high diversity, this isn't. But even in very small forest gardens, I encourage a minimum of 50 different species. In bigger forest gardens, I would say aim high, aim for a couple of hundred different species. and they're not all necessarily crop plants. Some of them will be crop plants, some of them will be plants perhaps to attract beneficial insects, attract bees, or attract other pollinating insects, or attract insect predators of potential pests you might get in a food forest system. Some plants might be there as nitrogen fixers to feed other plants. Some might be there as dynamic accumulators to feed other plants with other nutrients apart from nitrogen. So plants might be there for all sorts of system uses in addition to the actual crop plants that you might well harvest. So actually getting to that 200 species number is actually not that difficult. Once you get down to it, it's really not that difficult. But we're not used to that kind of diversity in our growing systems. You know, even if you're a commercial annual vegetable grower, you might be growing 20 different types of annuals, and we're talking about 10 times that in terms of species diversity. So it is a big leap for growers used to growing just a few things. Inoculants are worth looking at as well, because inoculants can improve plant performance considerably, particularly in a soil that has been very badly treated. So it's been in chemical-based agriculture, for example. In terms of the bacterial and microbial and mycorrhizal health, it might be very poor in those kind of soils. And certainly in those kind of soils, I think it is worth looking at inoculants, although the evidence from trials of inoculants is pretty mixed. So generally, if you've got a very healthy soil and perhaps there's trees nearby, I would say probably don't bother using mycorrhizal inoculants because the mycorrhiza will be nearby anyway, or they'll soon move into where you plant. However, if you're planting a long way from any trees, and particularly in a soil that's been abused, in the recent past, then yeah, I think I probably would use inoculants quite often, particularly mycorrhizal inoculants when I'm planting new trees and shrubs and so on. So that's worth considering. Use of animals in the system can also increase carbon storage. So basically it's the manures from animals increase growth of your plants, so increase the carbon stored in your plants. However, in food forests and forest gardens, the animals usually used are birds, particularly ducks, sometimes chickens, maybe geese, have all been used. Larger animals not so often used in food forests because they tend to eat all your low perennial crops. So it's not really a very good outcome. But the manures from birds like ducks and chickens and geese are very high in nitrogen. And there is a downside to that, and the downside is that after they're excreted down on the ground, you get nitrogen oxide emissions. Now, nitrogen oxides are very, very strong greenhouse gases. So if you have a lot of birds of this nature in your growing system, you're going to have a lot of nitrogen oxide emissions, and that will probably outweigh any benefit you get in extra carbon storage from having those animals there in the first place. So I would always advise a low stocking density. In terms of absolute numbers, there's not enough information out there really to give sensible advice on that. I have a guesstimate of perhaps 20 ducks per hectare, something like that. But that is very much a guesstimate, and I don't claim to have really good evidence behind that figure. It's important to consider that. It's important to consider that. You will of course get wild birds always in a food forest system, and they will do the same thing. They'll bring in some nitrogen, and if you've got a very healthy wild bird population who hopefully aren't damaging your crops too much, maybe you don't actually need domesticated poultry to give you that boost in biomass production. Also, whilst researching this paper, I came up with I discovered this graph in a different paper, which shows the global carrying capacity for terrestrial vertebrate biomass. That includes us, of course, as humans, and all the kind of domesticated animals you might keep. And the global carrying capacity is that little dotted line at the bottom there, which has been going down for the last 12,000 years because we've been wrecking the environment. And yet the number of humans and domesticated animals has been going up rapidly, as you can see, and we're way above the current carrying capacity of the Earth already. We're like 5 or 6 times over the carrying capacity now, and of course it's going to get worse in all likelihood unless a lot changes very quickly. So my point about showing this is I would say reconsider, should we be adding even more domesticated animal stock to the Earth when already we've got much too many. I think that's worth considering. So on to how to maximize the rate of transfer of carbon from that biomass where we've been storing loads into the soil where it is always more stable. Well, there's various things you can do to help that process. One is make sure your soil is decompacted, because decompacted soils can store much more carbon than compacted soils. And of course, soils that have been in agriculture are usually compacted pretty badly. Certainly agriculture in the Western world, maybe not everywhere, of course. And if you start a project on land that's been in agriculture, and is more than likely it's be compacted from a combination of heavy machinery being driven over it, and also animals grazed at inappropriate times. When it's wet, large animals' hooves can actually do a lot of damage to the soil structure through compaction. So decompaction, of course, in terms of food forest projects, it should happen at the beginning, hopefully. So you need to find out if your soil is compacted, do tests and so on. And if it is compacted, do something about it. You can do 2 things really. One is, ironically, using more big machinery to try and decompact it. So using a subsoiler on the back of a big tractor, which is basically vertical tines that are dragged through the soil. So it doesn't turn the soil, it's not like ploughing, but it does break up compacted soil layer, which is usually in the top 30 or 40 centimetres of soil. And of course after that you make sure that tractor doesn't drive on it again. So that's one thing you can do on a field scale, which is relatively easy and can have very, very fast effects. The other thing you can do both on a large scale and a small scale is actually use plants to help decompact soils, and the plants that do that tend to be deep tap-rooted plants with very strong tap roots that can basically drill through those compacted layers and start opening them up and letting worms go down and so on, and basically improving the soil. So a lot of plants will do that, but they can often take many years to do it. So it's a much slower process. And in fact, some of the plants we like to call weeds are doing that. Things like docks and dandelions, very common weeds in agriculture. What are they doing? They're actually trying to decompact the soils that agriculture has damaged. They're actually trying to improve those soils again, so they're actually doing some good, although farmers tend to hate them, of course. So there are other plants. I wouldn't necessarily advise you go and sow a load of docks and dandelions on your field. There's probably other plants you want to use instead of that, shorter lived, deep-rooted plants, things like annuals, things like borage, biennials, things like evening primrose, or perennials that are maybe of greater value than docks and dandelions, things like sorrels, for example, which are very deep-rooted, and plantago species. So all these can be used, oversown sometimes onto existing cover, and will start that decompaction process. Another technique really important is that any thinnings, tree thinnings, so those nurse trees, for example, if they're cut out that I talked about earlier, or prunings, of any kind, prunings from trees, prunings. I often prune those tall trees that I grow, which are often things like Italian alder. I often prune off the side branches as they grow to push the canopy up, let more light in underneath for other things. And so all that kind of pruning material should go down straight onto the forest floor, unless there's some kind of serious disease on it where you may want to actually take it away and do something else with it. That material should go down flat on the forest floor for at least a proportion of the carbon in that material to be able to be stored back into the soil. Now, of course, what happens when you do that, you cut off branches and you throw them down on the floor. The branches you throw down often have other side branches that stops them sitting flat on the soil. So I would prune those off, or prune your branches into smaller sections so everything lies pretty nice and flat on the forest floor. And that will speed up the process of decomposition because they'll stay much more moist being in contact with soil the whole time. It also means that you're not tripping up over branches the whole time as you're walking through your food forest, which is also quite important. That material should be laid flat. And when I was doing the research for this paper, I thought beforehand, there's bound to be masses of people have looked into the decomposition of woody material on the soil surface to see how long it takes to break down, how much carbon goes from those bits of branch or log back into the soil. Well, I was very wrong. There's almost no research at all being done on that. Shocking. The number of papers I could find is less than the fingers of one hand. It's very, very few. And so we're really lacking in good science telling us what's happening through this process, and even how much carbon is going to transfer from those logs into the soil. Now, in the food forest system, my reckoning is something like 60 or 70% of the carbon in those logs and woody prunings will end up stored in the soil through the decomposition process. The rest of the carbon will go back into the atmosphere, so you're bound to lose some of it through the decomposition process. The organisms doing the decay will be releasing some of that carbon as CO2 back into the atmosphere. So you're bound to lose some. There's nothing you can do about that. But a majority should get back into the soil and be stored in the soil. Okay. Use of wood chip and high carbon mulches. Well, similar to the previous slide, there's a lot of carbon, of course, in this material, and again, a good proportion of that carbon will end up being stored in the soil. How much? Don't ask me. There's been no research. There's really no figures at all on this. Incredible. What's science been doing when there's these important things to know? Of course, one of the problems about these kind of projects in science is they're long-term projects. You need 10-year projects, and science only gets 3 or 5 year funding at most, which is hopeless if you're looking at long-term ecological systems. From wood chip, you're probably going to lose more carbon into the atmosphere than from logs because it has such a high surface area. But so it's probably not 60 or 70% going back into the soil like it probably is with the logs, but it'll be a significant amount. And if the wood chip is a waste product you're getting from somebody else, then of course it's just an addition to your system. I actually use wood chip dropped off by tree surgeons, and it's a waste product for them, so that's fine with me. And I use deep wood chip mulches to prepare ground often of 15 to 20 centimetres, so that's 6 to 8 inches deep on new ground. Stumps, ideally you leave those to decompose in situ. Now, of course, the reason you might not want to do that if there's nasty fungal pathogens around, things like honey fungus, which can of course attack stumps and then potentially move from those stumps to living trees and then kill them. So if you have a lot of that around, you might not want to leave stumps to decompose, or indeed you might want to try and inoculate those stumps with a fungus deliberately before honey fungus can get in there, something like oyster mushroom, for example, and actually get a crop from those stumps, which is possible. Another another interesting fact is that the carbon that is stored in soil from woody material on the soil, so that's logs you've left on the soil surface, or from stumps, dead stumps, it never goes more than about a metre away in the soil. So carbon storage is very local to where those stumps are or where those logs are lying on the ground. So when you're talking about those, woody prunings, you should really spread them around well. Not just have one or two piles of them here or there, but really spread them out nicely, because that will spread out the carbon storage, and overall that is bound to increase the amount of carbon stored than putting them in a few piles in a few different places only. Okay. So the third part of this I'm going to look at is what you can do to minimize carbon losses from soil. Again, most of this, a lot of you will know, I'm sure, but it's worth going over these points. Use of swales or terraces, very well known in swales, well known in permaculture circles, of course. And the idea is you want to stop any water erosion on slopes. So swales are very suitable in climates where you get very long hot dry spells and the soil surface gets very dry and very hard and actually impermeable to water. So then if you get a heavy storm and lots of rain, it just all washes straight off. It doesn't soak in. So swales are definitely more appropriate in some climates and certainly on some soils than others. So they're not necessarily appropriate everywhere. But if you get soil erosion and you lose soil, you also lose a load of carbon. Both the carbon in the soil itself is washed away, of course, but also quite a lot of that carbon will end up as carbon dioxide back into the air as well. So anything you can do to stop erosion is worthwhile, and certainly that includes swales or terraces. Terraces, of course, take a lot more in terms of construction than swales. And in fact, building both, you might lose a bit of carbon during the construction process. In swales, you might lose a bit more in constructing terraces, because constructing terraces actually takes a lot of work. You have to remove all the topsoil, make the terrace, put it all back again. You're bound to lose carbon from the soil in that process. But the carbon you save afterwards will usually more than compensate for any carbon you've lost in the process of making these things. Site choice is important for food forests. Avoid steep sites. Steep sites should be completely forested with full canopy closure above to give maximum soil protection. Remember, food forests are not forests. They're much more open than forests. You don't have a closed canopy, so you are more likely to get soil erosion on a steep site with a food forest than you are with a closed canopy forest. Steep sites should be permanently forested. That doesn't stop you doing some kind of forest farming, perhaps in the understory underneath. There's various things you could do underneath potentially. Depends how steep it is, of course. But really, the trees should be left to their own devices, and very little interference, I think, in those to give maximum soil protection. If you do have water flow on site through streams or rivers, slow it down. Build ponds, slow stream flow down. These are kind of leaky rock dams on the left, you can see here, and there's a beaver dam there on the right. Anything you can do to slow water flow will slow soil erosion and will slow carbon loss from your system. So, look at all that. And if you've got water on site, slow it down. And of course, slowing down water can sometimes decrease your cropping area. So particularly with beaver dams, they will tend to increase the area of water because they're making lakes basically, and you will lose some cropping area, near that water, water feature. So that's a consequence that's inevitable, and basically you just have to put up with that. You're getting something very good for putting up with that in return. Windbreaks as well obviously reduce wind erosion. That's what they're one of the reasons they're there. Windbreaks are well known and well used in agroforestry systems, and less well used in agriculture, I have to say, in many parts of the world. And farmers have I generalise, but a lot of farmers have an aversion to planting windbreaks because they think they're losing crop ground. But windbreaks increase the productivity of whatever crop you're growing by 10 to 20% on average. So, whether that's wheat or a tree crop or whatever, your yields go up by 10 to 20%. And the windbreak itself usually takes much less than 10 to 20% of the area on your growing site. So in fact, they more than pay for themselves, and they can have a lot of other benefits as well. They can obviously be designed for good for pollinators. They can have crops sometimes. This little windbreak here you can see is Rosa rugosa, apple rose, which has fantastic edible and useful flowers, fantastic large edible rose hips as well. So there's no reason you can't also have productive windbreaks, at least on the inner edges. So they're more than worth considering when you're setting up a system. Biochar, I won't say an awful lot about this, except that the results from using biochar in experiments in northern and temperate climates are very mixed. There's some positives, there's some negatives, and overall it's very difficult to give an overall judgment on whether or not it's worth using biochar. But it is a way of fairly long-term storage of carbon into soils. Now, not necessarily 1,000 years, which some people will quote you after referring to systems in the Amazon, for example. Sometimes in northern climates it might only last 30 years in soil. So time it lasts is very variable, but it is a way of fairly long-term storage of carbon into soil. And you can see on the right, that's where I was going to plant a tree, and I put a little handful of biochar down at the bottom to increase the ability for carbon storage, increase the ability of mycorrhizal fungal habitat there under the tree once it's planted. And whether or not that's a worthy thing to do in my climate or my soil, I don't know. There's still a lot to learn about the use of biochar, and I believe there's other speakers at this conference, speaking about biochar. I'll be very interested to see what they say about it. Minimal soil disturbance is important, both before planting and during planting. So before planting, it depends what you're starting with, of course, but if at all possible, avoid ploughing, avoid rotivating, all that kind of soil preparation that you might do to sow an annual crop. You don't need to do usually for creating food forests. And what I'd say is, clear ground instead of by ploughing or something like that, clear ground using mulches perhaps. And in terms of planting, preferably plant small plants, because small plants need small holes. You don't need to dig so much. Each hole's only going to make a tiny impact, of course, on your carbon emissions and your carbon storage, of course. But potentially there's a lot of holes, when you're planting a lot of plants. It could be several thousand holes, over an acre of food forest, or even tens of thousands. So, potentially, it's worth actually considering that. Small plants often establish better, although if they're prone to some kind of pest or disease you happen to have around, or like slugs, small plants can be a problem sometimes. So there may be exceptions to this, but generally speaking, try and do things on small scale like that. Ground covering plants, really, really important, and some of the pioneers of food forest systems in northern climates, I don't think really got this. Ground cover plants are very, very important for many reasons. Only one of which is, of course, they'll improve the rate of carbon storage in soil from woody biomass on the soil. So those logs that you've cut from your prunings, you've left down on the forest floor surface, Then if you have them amongst ground covering plants that are growing above them, then of course they'll stay damper, more moist, because the sun can't get at them so easily. They'll decay quicker. The carbon will get into the soil quicker. It's all about speed of progress of carbon down into the soil. And ground covering plants can really improve that, as well, of course, as making your whole food forest much more resilient, because it'll stop undesirable species coming in, that we often call weeds, but also it'll, of course, directly protect the soil surface from climate extremes, protect the soil surface from droughts, from heavy floods and stuff, all of which can damage the soil and lead to soil carbon loss. So ground covering plants, keeping that soil covered with a green mantle, preferably all year, is ideal. But of course it depends on your climate whether that's even possible. In very northern climates where you get snow cover, that will actually protect the soil quite well. But you know, a lot of the sorts of plants we want to grow in food forests down on the soil surface are herbaceous perennials, so they die back in the winter. So try and think, how could you maybe mix those with other plants, maybe lower plants that stay evergreen over the winter? And there's ways of doing that, and there's different species you can use to do that, so you maintain that green cover even over winter. Good design of paths and tracks. Well, it's a good idea to design them well in any case, of course it is. But remember, all erosion leads to carbon loss, and that includes path erosion or track erosion as well. So think about that, you know, on slopes particularly. You know, there's I mean, I'm not going to go into all the techniques of good path design and good track design. There's lots of information out there for you to find that out. But don't think it's just a question of, oh, I'll have a track here and never thinking about it again. You know, do think a bit more about it than that. Reduce the use of soil cultivation as much as you can. All soil cultivation causes carbon loss. So this really applies mostly if you're still growing some annuals in your forest gardens. And of course, you might well be. Lots of people do. And here this shot shows one of our small forest gardens. And there's an annual veg bed there growing sweet corn mixed with courgettes. And there's some sunflowers down the end there. Lots of people want to carry on growing a few annuals, of course. Why not? They're great food plants, but it's a question of how you grow them. If you're really thinking of carbon storage, basically try and use no-dig systems. You know, by doing that, you know, unless it's a root crop or tuber crop you've just got to dig up, then you can really reduce soil cultivation a lot. Avoid bare soil at all times. You know, try never to have bare soil. If you've cleared ground using mulches and maybe remove those mulches and there's bare ground underneath to plant, and yeah, plant immediately and mulch immediately as well. You know, there's lots of different sorts of organic mulches you can use. Some may be free to use, some, especially if they're local. That's a good option. There's woodchip here, or a mixture of wood and bark chip really on the right. You can see. So I often use that around young plants planted out. That's buckler leaf sorrel there on the right, you can see. Small plants of that have been planted out and then mulched around just to protect the soil, and also, of course, reduce the amount of work in weeding. It also does that. So that's all good. You know, we all want to do less work if we can. So that's generally very good. And of course, bare soil is very prone to being damaged by weather extremes, which will cause carbon loss. Avoid chemical stressors. Well, yeah, makes absolute sense, and probably if you're watching this, you probably don't need to be reminded of that. All these things, fertilizers, pesticides, herbicides, they all damage soil life and reduce carbon storage, and that includes overuse of even of organic fertilizers. So you know, just be wary of using those things. And liming with silicates is another option. If you're an organic grower and you've got very acid soil, normally you will probably want to lime with something like limestone or dolomite, which are calcium carbonate compounds. And if you use those, a proportion of that calcium will go up into the air as carbon dioxide. Whereas if you lime with using silicates, usually olivine, which is often found in rock dusts, you don't get any carbon going into the air. So if you have the option of doing that, yeah, use that, because it'll just reduce the carbon impact. So in summary, with good choices, good techniques, young temperate food forests can sequester 4 to 5 tonnes per hectare per year of carbon in biomass and soil combined for several decades. That's a statement based on research done in our forest garden, which is 27 years old now, and of course those figures, they'll vary in different climates or different soils and so on, so don't take that as a given for wherever you're starting a forest garden or a food forest. However, that is a fantastic rate of carbon sequestration, only really bettered in our climate by planting forest, where you can't eat very much out of either. So remember, food forests have lots of crops for us. That's the point of them. They're not just forests. So I would say we should all strive to become carbon negative, both personally and in terms of whatever projects we're involved in, for the good of the planet and ultimately for our own health. So thank you very much. The references are available that I've used throughout this paper if you want them. Thank you.